See, and my topic is memory management. Here, I'm going to discuss about fixed partitioning and variable partitioning in RAM. When a process has to be loaded in the RAM, the memory has to be divided into blocks. It is known as partitioning. So I discuss these about fixed partitioning and variable partitioning. Fixed partitioning. Partition main memory into a set of non-overlap memory regions called partitions. These blocks, each block is called as a partition. Fixed partitions can be of equal or unequal sizes. Left over space in partition after program assignment is called internal fragmentation. So each process is loaded to execute for execution. When the process size is less than the partition size, the left memory in the partition is known as internal fragmentation. Placement algorithm with partitions, equal size partitions. If there is an available partition, a process can be loaded into that partition. Because all partitions are of equal size, it does not matter which partition is used. If all partitions are occupied by blocked process, choose one process to swap out to make room for a new process. When RAM memory is fixed, when many process has to be executed, the RAM is left with no space. Because of this problem, we use a technique called swap out or unswap in. And dynamics of fixed partitioning. Any process whose size is less than or equal to a partition size can be loaded into the partition. If all partitions are occupied, the OS can swap a process out of the partition. A program may be too large to fit in a partition. The programmer must design the program with overlays. The variable partition seems to be here. The diagram shows that there are initially process 5, 8, and 2. The RAM memory is filled here. When other process has to be loaded into the RAM, the process 8 is swapped out to load the other process. And when the process 8 is swapped out, process 9 is swapped in and followed by process 10. So this is the overall overview. When the RAM is initially empty, first loaded process 1 and 2, 3, and RAM left with no space. So I swapped out process 2, and here process 4 is swapped in, and here also RAM left with no space. For that, program 1 is left swapped out and process 2 is swapped in. Internal or external fragmentation. There are really two types of fragmentation: internal fragmentation and external fragmentation. Internal fragmentation. Allocated memory may be slightly larger than the cache memory. The size difference is memory internal to a partition, but not being used. External fragmentation. Total memory space exists which has a size n request, but that memory is not contiguous. We find external fragmentation with dynamics and internal fragmentation with fixed partitioning. So thank you. This is my seminar topic.